All right, ladies and gentlemen, here we are. We are on lesson 9 of Unit 8 today. I hope you noticed in the module for this week that we are skipping lesson 8. We are not doing lesson 8, so we are now in lesson 9, which is something called the mean. We're going to learn what the mean is today. For our first activity, though, we got a little brain buster math problem, which I really, really like. If you haven't tried this one yet on your own, please stop the video right now and try it for a couple of seconds. I think you'll get it if you think about it really carefully. Here's a hint for you. Think order of operations. What do I have to do first to solve this problem? Think about that and then go try it for 30 seconds and then come back. All right. You're back. Hopefully you've come up with an answer. Here's what I noticed. I noticed that I have a set of parentheses, which means I'm going to have to do the math inside the parentheses first. I'm going to have to do all this addition first. And then the last thing I'm going to do is divide by 4. And in my instructions, it says that I want the answer to equal 4. So if I have to divide by 4 and equal 4, then what must this sum be? Well, 16 divided by 4 equals 4, right? So all that I need are 4 numbers that add up to 16. Now we have all the numbers 0 to 9 to choose from, so it really doesn't matter. There are lots of possible answers here. Here's one. 2 plus 8 is 10. And then 4, no, let's see. 4 plus 3, no, 4 plus 2, no, we've already used 2. So maybe I'll have to do 5 and 1 is 6 for 16. That works. So 8 plus 2 is 10, plus 5 is 15, plus 1 is 16. Or you could do, there's a million different ways you could do this. 7 plus 3 is 10, plus 2 plus 4 is 6. That would work, right? Lots of different possibilities for this one, so I hope you came up with one on your own. Well done. Now for the beef of our lesson today. Activity number 2. Spread out and share. All right, here we go. The kittens in a room at an animal shelter are placed into 5 crates. These boxes represent the crates, it looks like, and these poor cats have sweaters on. That's really sad. Okay, the manager of the shelter wants the kittens distributed evenly among the crates. How might that be done, and how many kittens will end up in each crate? Well, we're going to have to move the cats around, right? Move cats into other crates. Okay, right now this crate is too full. So let's take one of these guys and move him over here. Now I'm just going to do circles for cats because I can't draw cats. So we lost that guy and now he's over here. Okay, but they're still not even. What if we were to take... See, this got 2. Let's take this guy and move him over here as well. So now I have 2, 1, 3, 2. Oh, that looks easy to fix. Let's take this guy and move him over into here. Now I have 2 here, 2 here, 2 here, 2 here, and 2 here. So there we go. How many kittens will end up in each crate? 2 kittens per crate. Now, could you have moved them in different ways? Yes, we could have moved them in different ways. But in the end, the way to get them evenly distributed is to get 2 in each crate. Okay, so there's number 1, part A. Let's keep going. Part B. The number of kittens in each crate after they are equally distributed is called the mean. The number of kittens per crate, or the average number of kittens per crate, okay? So the mean is exactly the same thing as the average. You've learned average before, and now you know a new word for it. So the mean number of kittens is exactly the same thing as the average number of kittens, okay? Explain how the expression 10 divided by 5 is related to the average. Well, how many cats do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 cats total, right? And what is the 5? Well, that's the number of crates. So if I take all 10 cats and I divide them evenly into 5 crates, what do I get? 2 cats per crate. That is the mean. Again, it's the total number of cats divided by the number of groups, or the number of crates in this case, gives me the mean number of cats. Okay? Pretty great. Moving on to part C. Another room in the shelter has 6 crates. No 2 crates have the same number of kittens, and there is an average of 3 kittens per crate. Draw or describe at least 2 different arrangements of kittens that match this description. Okay, so we're going to have, I'm going to draw pictures because I think it's easier, but if you want to describe, that'd be fine too. We need 6 crates, so I'm going to draw just little pictures here of 6 crates. 1, 2, 3, 4, 5, 6, and these are just going to be really crude pictures, but I need 2 different sets of 6 crates. Okay. Now it says that no 2 crates have the same number of kittens, and there is an average of 3 kittens per crate. So if there's 3 kittens per crate and there's 6 crates, then I know I have 18 kittens. Does that make sense to everybody? Because 18 kittens divided by 6 crates gives me my average of 3 kittens per crate. Now, that doesn't mean I'm going to put 3 kittens in every crate, because it tells us we can't do that. No 2 crates have the same number of kittens. So we can't actually put 3 kittens in each crate, but we have to have a total of 18 kittens. So what if I put 1 kitten in here, 2 kittens in there, 3 kittens in there, and 4 kittens in there? How many do I have so far? 4, 7, 8, 9, 10. I have 18 left, so I need 8 more. So if I do, I can't do 5 and 6 because that's more than 8, right? And I can't repeat any of these numbers. The only number I haven't used yet is 0. So what if I were to do 0 and 8? Does that make sense? So now I have 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 cats. Would my average still be 3? Yes, because 18 total cats divided by 6 crates is still 3. All right. So there's one way of dividing out these kittens. Let's think if we can come up with a different way. Well, we still know we have 18, so I like the strategy we used before. We've just got to think of a different way of doing it, right? What if we, instead of having a 1, what if we started with a 2, and a 3, and a 4, and a 5. Do we have enough for that? That's 9, 10, 11, 12, 13, 14. So 14, we have to get 4 more kittens in these 2 spaces. 14, 5, 9, 10, 11, 12, 13, 14. Yeah, we need 4 more kittens. So either 3 and 1, which we've already used the 3, 2 and 2, which we've already used the 2, and 4 and 0, which we've already used the 4. Okay, so we can't do, let's take away the 5 and make this a 6. Okay, so now we have 10, 11, 12, 13, 14, 15. I just need 3 more. 3 and 1, no, 3 and 0 and 2 and 1. We can't use the 2 and we can't use the 3. So we're going to have to take away another one. Let's do 7 in this one. That's 7, 11, 12, 13, 14, 15, 16. That's either 1 and 1, which we can't repeat, or 2 and 0, which we can't repeat. I think we're almost there. Let's do an 8 in this one. 8, 12, 13, 14, 15, 16, 17. Now I can do, 1 and 0, but that's exactly the same as this. Dang. Oh, man. I thought I was on a roll. Well, okay. Maybe I can't just change one of the numbers. Maybe I have to change two of them. So let's go back down and do a 7 and a 5. Or a 7 and a... Well, let's see what that gives us. 7 and 5 is 12, 13, 14, 15, 16, 17, 18. That worked. That totally worked. So now I have 18 again, right? And I don't have any repeating numbers. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Done. We figured out two ways. Now, I happen to know there are more ways than that. This is kind of a fun little brain teaser too, isn't it? Basically, all the numbers have to add up to 18 and no repeats. Okay? That's all you have to know in order to answer those questions. Okay? Number 2, 5 servers were scheduled to work the number of hours shown in the table. They decided to share the workload so that no one would work, so each one would work equal hours. So server A was scheduled 3, server B was scheduled 6, server C was scheduled 11, D 7, and E 4. Well, that's not very fair, right? So they want to make these hours fair. On the grid on the left, draw 5 bars whose height represent the hours worked by servers A, B, C, D, and E. So we just have to turn this data into a bar graph, right? So this is going to be a bar graph. Server A, B, C. Oh, I'm going to space those out more. A, B, C, D, and E. A, B, C, D, and E. A worked 3 hours, so her bar... Oh, there are actually grid marks on here. I just can't see them very good. So there's her bar, or his bar, we don't know. Server B works 6 hours. Server C is 11 hours. Whoops, I'm too high. And I could probably space these out now that I know that there's grid marks on there. I'm kind of following a pattern here. Kind of hard to see them. D is 7. I think 7 is right there, isn't it? Or maybe that was 8. That's 7 right there. So there's 7. And I'm kind of running out of room. I think I'm too far over. I can't see the grid marks very well over here, so I think I scooted over too far. But we'll just eyeball it. There's D, and then E has 4. Okay, so there's my bar graph for the first part of this problem. Okay. Now it says... Let's see, on the grid on the left, draw 5 bars whose height represents the hours worked by servers A, B, C, D, and E. So again, this is not numerical, so this is a bar graph, right? Now let's see what we're supposed to do on this blank one here, part B. Think about how you would rearrange the hours so that each server gets a fair share. Then on the grid on the right, draw a new graph to represent the rearranged hours. Be prepared to explain your reasoning. Now, I think we can think about this mathematically, right? How many total hours do I have to split up? Well, 3, 9, 20, 27, 31. It's not a very easily split up number. Well, I have 31 hours to split amongst 1, 2, 3, 4, 5 servers. Does that make sense? So it's 6 hours and a few minutes. Let's see what 31 divided by 5 actually is. That's 30 with a remainder of 1, decimal point, 0. 5 goes into 10 twice. So 6.2 hours is the exact answer. Okay. So what that tells us then is that each of my bars now are going to be just over 6 hours tall. Okay, so once again, I've got A, B, C, oh gosh, well, we'll see how it goes, D and E. And A's bar is going to be just over 6 tall. B's bar is going to be same height, just over 6 tall. C's bar is going to be just over 6 tall. D's bar exactly the same. Does that make sense to everybody? So these are all 6.2, 6.2, 6.2, 6.2, 6.2. Where this one was 3, 6, 11, 7, and 4. Okay, I should shade those in. Now you can tell on the graph. Now their time is exactly fair, isn't it? Whereas before, this poor guy had a ton of hours and this poor girl or guy or whatever had like none, right? So there we go. That is totally fair share, isn't it? Okay, next problem. Oh, we forgot to explain your reasoning, right? Well, showing this math kind of did explain it. We found the mean, right? We took the total, I'm probably not on the screen. This math up here, right, is what I'm talking about. We took all this math, 31 hours total. I added up all the hours, and I divided it by how many servers we had to work, and that gave me my mean or my average, right? And that's how I determined my bar height, okay? So explaining that in words in part C is all you really, or yeah, part B, is all you have to do to finish this out, right? Each server would work 6.2 hours for a fair share or mean, right? Okay, very, very good. Now, part C. Based on your second drawing, what is the average or mean number of hours that the server will work? Well, there it is right there. We actually just answered that, 6.2 hours. Okay, explain why. We can also find the mean by finding the, oh, look at that. I should have looked ahead in this lesson. See, this is what I get when I don't look ahead and I just kind of plow into it. I answered questions earlier than I needed to. Well, that's exactly what we did mathematically, right? 31 hours is the total hours worked. Hours worked divided by the 5 servers working, right? That's how we find the mean equals the mean, right? That's what we did. Which server will be the biggest change, will see the biggest change to their work hours? Which server will see the least amount of change? Well, if we compare our graphs here, server A went from 3 to 6, so she gained 3 hours. Server B went from 6 to 6.2, lost very little. Server C went from 11 to 6, so he lost 5 hours, almost 5 hours. So that's the biggest change so far. So server C lost just under 5 hours. Server D went from 7 to 6.2, so not quite an hour lost. And server D went from 4 to 6.2, was just over 2 hours gained. So I think our biggest change was for this 11 guy. So which server will see the biggest change? Server C. Lost almost 5 hours, right? And then it says which server will see the least amount of change? Well, this server B only went from 6 hours to 6.2 hours. Server B only gained 0.2 hours. And by the way, 0.2 is what, 15 minutes-ish? You know, they'd only gained a couple of minutes, maybe 12 minutes-ish. Not very many minutes. Okay, awesome. So that is activity number 2 done. Beautiful. Now we're ready for activity number 3. And I have lost my second page of activity number 3. Here it is. I have too many papers. There we go. Activity number 3, getting to school. It says, oh yeah, this is our Are You Ready for More? I was going to say server F. Okay, so this is a continuation, obviously, of the previous one, but it is optional. So thank you to all of you who have told me you are doing these optional Are You Ready for Mores. I think they're a lot of fun, and I know the people who have mentioned it to me have said that they enjoy these ones. These are fun this time. Lesson 9 or activity 9.3. Here we go. For the past 12 school days, Mai has recorded how long her bus rides to school take in minutes. The time she recorded are shown in the table. Okay, so the first day it took 9 minutes, the second day 8 minutes, the third day 6 minutes, fourth day 9 minutes, etc., etc. Okay, so these are the number of minutes it took every day for 12 school days. Okay. Part A asks us, find the mean for Mai's data and show your reasoning. Now, we've just talked about this. We find the mean by finding the total number of, in this case, minutes, right? So how do we find the total number of minutes? Well, we have to add them all up, right? 9 plus 8 plus 6 plus 9 plus 10 plus 7 plus 6 plus 12 plus 9 plus 8 plus 10 plus 8. Now, ladies and gentlemen, for the first time in a very long time, listen for it, wait for it, you may use a calculator. What? Yes, on this lesson and on any future lessons in Unit 8, you may use calculators because it is so important to get this sum correct. I don't want adding errors to make us not get the right answers. Does that make sense? So use a calculator, but use it carefully, okay? Go grab a calculator right now if you've got one handy, or you can use a phone, you can use your parents' phone, whatever you need. Find a calculator, and let's add these up. Pause the video right now and go and do that. All right, I'm just gonna do this in my head because my calculator happens to be on my phone, which happens to be videoing this video. So I can't use that. So it's okay. I'm just going to do this in my head. 9 plus 8 is 17. Plus 6 is 23. Plus 9 is 32. 42. 49. 55. 67. 76. 84. 94. 102? Did I do that right? I hope so. I don't know if I did. I bet you I'll hear it from you guys if I didn't. There's a bunch of students who like to tell me when I do things wrong, which I actually really do appreciate. But I think I'm right. Let me go through one more time. Maybe I'll go backwards and see if I get the same thing. 8 plus 10 is 18. Plus 8 is 26. 35. 47. 53. 60. 70. 79. 85. 93. 102. Yeah, I think I'm right, 102. Okay, so there's my total number of minutes. Now I'm going to divide that. So I have 102. Now I need to divide that by how many school days, right? How many crates or how many items I have here, how many data values I have. And I know I have 12, but just to be sure, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going to divide this by 12. So to find the mean, as a recap, you take all the numbers in your data set and you add them together. And then you divide by how many numbers you have. Does that make sense? Take all the numbers you have in your data set and you add them together. You take that answer and you divide it by how many you had. Now, once again, you can use a calculator to do this. And I happen to know the answer to this final answer because I do know the final answer. But I can do the longhand if you want me to. But the answer is 8.5. Okay? So 8.5 minutes is the mean of Mai's data. Okay? In this situation, what does the mean tell us about Mai's trip to school? What this tells us is that the average bus ride takes 8.5 minutes. Okay? Now, does that mean that it's going to take her exactly 8.5 minutes every single day? No. In fact, we found out from her data that it doesn't, right? But what it does tell us is that on average, she can expect to take 8.5 minutes per day to get to school, right? That's what the mean tells us, okay? Moving on to number 2 here. In number 2, it says, for 5 days, Tyler has recorded how long his walks to school take in minutes. The mean for his data is 11 minutes. Oh, so we already know his mean. That's awesome. It says, without calculating, predict if each data set shown could be Tyler's. So if we know that the mean is 11, we have to decide, could these be his data for that week? Well, okay, if I have 1, 2, 3, 4, 5 days, and the mean is 11, then these should add up to 55, shouldn't they? Because 55 divided by 5 is 11. So do we think that these 5 numbers are going to add up to 55? That's one way, but it says without calculating. Well, we also know that 11 needs to be that center, that middle of our data, right? The average. So we can think of it as that way. Is 11 going to be the middle of this data? I don't think so, because look how many numbers are less than 11. I don't think data set A is going to work because too many of our data values are less than 11. Some of them are going to have to be more than 11 in order for 11 to be the middle, right? Let's try data set B. Okay, well, 3 of the numbers are bigger than 11, and 2 of them are less than 11. So that's about as close as you can get. So that's a good possibility. Let's keep that in mind. What about this one? Well, we've got one that's way more than 11. One that's not as far away, but a little bit less than 11. And then, I don't know, these are tricky without computation. Let's think about this again. What do we think about this last one? 11, 11. 2 of them are 11, but nothing is bigger than 11. So I think data set D is out. So the best I can tell right now, B and C are good options. The only way to know for sure which one is the best option, I think, is to do the math. Which one actually adds up to 55? Which I don't think they both will, right? In fact, this is 20, 31, 37, 46, 56. If I did my math right, this is 56. And if I do the math on this one, that's 25, 32, 41, 55. I think it's data set B. But then again, I calculated, didn't I? But I was leaning towards data set B anyway because this 20 really worried me, right? I thought that was too far away. Anyway, I'm going to say data set B is the best. It's a prediction, right? So there's really no right or wrong answer here, but my prediction is data set B. Okay, and there goes my dog. Alrighty. Exactly. So we've made our prediction. Now in part B, it asks us to actually determine which one is Tyler's set. So let's see if I was right. I kind of cheated, didn't I? And actually added them up. But that's the way to figure this out. We can prove that it is by adding 12 plus 7 plus 13 plus 9 plus 14 and seeing what we get. We know we want to get 55, right? Because we know that 55 divided by 5 is in fact 11, which is what we wanted for the mean, right? So let's just double check my math here. 12 plus 7 is 19. 29 plus 3 is 32. This would be 41. 51 plus 4 is 55. So 55 divided by 5 is 11. So this is data set B is the correct answer. I was right, but I cheated. I'll give you that. But do you know how I got down to these two? And that's the most important. So even if you had guessed data set C, we would find that this is actually really, really close. It's just not quite exactly 11 if you do the math. Okay. Good, good, good. Moving right along. Oh, guess what? I thought there was one more part, but there's not. That is the end of our lesson, ladies and gentlemen. Hallelujah for that. Go ahead and read through that summary page. It really gives a really good definition for how the mean is the same thing as the average and how to find that. Really great diagrams and things to help you understand that. Again, there's our vocabulary words comparing an average to a mean. They are basically the same thing, but it'll explain each of those in the glossary for you. We are now ready for our lesson 9 practice problems. There are 6 problems today, and I do want you to do all 6 problems. So go ahead and dive into those and meet back with me in just a few minutes, and we will go over their answers. I know you'll do awesome because I know you will always
do your best because you deserve your best.
All right, let's grade lesson 9's homework, starting with number 1. A preschool teacher is rearranging 4 boxes of playing blocks so that each box contains an equal number of blocks. Currently, box 1 has 32 blocks, box 2 has 18, box 3 has 41, and box 4 has 9. So basically what we're trying to do here is we're trying to find the mean, right? We need to get an equal number of blocks in each of the 4 boxes. So let's find out how many total blocks we have. We know there are 4 boxes, so we can divide that by 4 to get our average or our mean, right? So we have 32 plus 18. Box 3 has 41, and box 4 has 9. Now, I know I said you can use your calculator, and you can. If you want to go grab your calculator, you most certainly can. But I just noticed something really cool about this problem, and that is that 41 plus 9 is 50, and 32 plus 18 is also 50. So 50 plus 50 is 100. So I didn't even need a calculator because I remembered my mental math tricks. Okay, so I know that I have 100 total blocks, and if I have 4 boxes, then I know I'm going to need 25 blocks in each and every box. So my mean is 25. Okay, that's going to help us, right? It says select all the ways he could make each box have the same number of blocks. So this is a select all problem. Let's look at A. Remove all the blocks. So take all the blocks out of all the boxes and make 4 equal piles of 25, then put each pile in one of the boxes. Well, that's the greatest way to do it, right? I know I need 25 in each box, so just take them all out and put 25 in each box. Smart, smart, smart. Part B. Remove 7 blocks from box 1 and place them in box 2. Well, let's see what would happen. If I take 7 blocks out of box 1, well, box 1 right now has 32. So 32 minus the 7 would put it at 25. Well, that worked. That put that at 25. Box 2, if I had 18 in it and I add 7, that would put it to 25. Awesome. But wait a second. Box 1 and box 2 are fixed, but what about box 3 and box 4? That didn't solve our problem. So B is not enough. Darn. Part C, remove 21 blocks from box 3 and place them in box 4. So if I take 21 blocks away from box 3, then that would leave 20 blocks in there, which isn't what we want. If I add 21 to 9, that's 30. No, that's definitely not what we want. Now I have 20, 30, 32, and 18. So that's no good. Part D, remove 7 blocks from box 1 and place them in box 2. Well, that's what we did before, and that worked great, right? And remove 21 blocks from box 3 and place them in box 4. But that didn't work. That would give us 25, 25, 20, and 30. So it's closer, but that's not quite right. Man, is there going to be another one? Let's see E. Remove 7 blocks from box 1 and put them in box 2. That works. We already tried that. Then remove 16 blocks from box 3 and place them in box 4. Oh, so now it's a different number. Let's try this one and see if it works. So instead of 21, now I am taking 16 away. 41 minus 16, oh my goodness, that's 25. So that worked. What's 9 plus the 16? Oh, that is 25. That works. So E is true. So our answers for number 1 are A and E. We got it. Good work, good work. Okay, on to number 2 now. In a round of mini golf, Claire records the number of strokes it takes to hit the ball into the hole of each green. She said that if she redistributed the strokes on different greens, she could tell that her average number of strokes per hole is 3. Explain how Claire is correct. Well, if she just rearranges this so that they all have 3 in it, that's kind of what we did with the cats before, right? Or we could do it mathematically and see if the mean is 3. I like that way because these are easy numbers to add together. 2 plus 3 is 5, 6, 10, 15, 16, 17, 20, 24, 25, 26, 27. So there's 27 total. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9. 27 divided by 9 is 3. So that did work. Explain how Claire is correct. She can find the mean by doing 27 divided by 9, and that is 3, right? She is correct. Number 3. 3 sixth grade classes raised $25.50, $49.75, and $37.25 for their classroom libraries. They agreed to share the money raised equally. What is each class's equal share? Oh, well, equal share is the same thing as the mean, isn't it? So to find the equal mean, just like we've done all these other times, we have to add up our 3 numbers and then divide by 3 since there are 3 numbers. So let's add these up. 25.50 plus 49.75 plus 37.25. Now, once again, you may use a calculator. I've got something under my paper making it difficult here. You may use a calculator, but I'm not going to. I can do this longhand. 0 plus 5 is 10. Carry the 1. 5 plus 1 is 6. Plus 7 is 13, 14, 15. Carry the 1. 5, 6 plus 9 is 15. Plus 7 is 22. Carry the 2. Don't forget my decimal point in there. I about forgot that. 2, 4, 6, 8, 10, 11. 7, 8, 9, 10, 11. Yep, I'm right. So that's the total amount of money raised is $112.50. So that's the top of my fraction or my thing, right? So I'm doing 25.50 plus 49.75 plus 37.25, all divided by how many there were, which is 3. So that gave me the 100, oops, I'm going to about wrote it wrong. The 112.50. Now I just have to divide that by 3. And I'm going to have to do that longhand as well because you guys have calculators, but I don't. 3 goes into 11 3 times, which is 9. 3 goes into 22 7 times, which is 21. 3 goes into 15 5 times, which is 15. All I have left is a 0, so I'm done. So the fair share is do you see me up here? I hope you see me up here. The fair share is $37.50. And I've kind of made my room squishy here, but the answer is right here. $37.50 is my fair equal share. Okay. Now it says explain or show your reasoning. I think I have shown my math pretty well. So I think we're good. Let's move on to number 4. In her English class, Mai's teacher gives 4 quizzes, each worth 5 points. After 3 quizzes, she has the scores 4, 3, 4. What does she need to get on the last quiz to have a mean score of 4? Explain or show your reasoning. Now, with this ugly bar right here, I don't have much room to work. But I noticed on my next page, I have a lot of empty space. So I'm going to use this empty space that I have on my next page to show my work for number 4, okay? So as I did before, I need to know the average, right? I want my mean to be 4. So here's how we got to set this up. Normally, when we find the mean, we take all of our numbers and divide by how many there are, right? So we normally do 4 plus 3 plus 4 plus, well, we don't know our next score. So I'm just going to do a blank because I know there's going to be a 4th quiz, right? And then after I divide by 4, my answer needs to be 4. This looks really familiar. This looks like that's the problem at the beginning of this lesson. Holy cow, they were pretty smart. But we need to figure out what's going to go in that blank. Well, once again, we know that if I divide by 4 and equal 4, this sum up here must equal 16, right? So what do I need to add to these to get to 16? Well, 4 plus 3 is 7. 7 plus 4 is 11. And I need 16, so I must need a 5. 5 plus 4 is 9, plus 3 is 12, plus 4 is 16. Now I have 16 divided by 4 equals 4. And that's what I need. So the answer to the question then, okay, is she needs, whoops, I'm combining my words. She needs to get a 5. She needs 100%, right? She needs to get 100% on quiz 4. In order to get a mean score of 4, she has to get a 5 on the next quiz, okay? And then it says explain or show, and here's my work. Hopefully you can show that in your workbook as well so that you get credit for that, okay? So that is number 4. All right, so moving on to number 5. It says, an earthworm farmer examined 2 containers of a certain species of earthworm so that he could learn about their lengths. Well, this looks kind of familiar, doesn't it? He measured 25 earthworms in each container and recorded their lengths in millimeters. Here are the histograms of the lengths for each container. Okay, so we've got histogram A and histogram B. Part A, which container tends to have longer worms than the other container? So let's see here. Which container do you think has longer worms? Well, one thing I noticed right off, look at this. This scale starts at 10 and ends at 80. This scale starts, well, at 5, really, right? 5, 10, 15, 20, but ends at 65. So that's already an indicator of which one has longer worms, is the fact that there's worms longer than this one even has, right? Because they have 1, 2 worms that are longer than any of the ones these guys have. The other thing, the reason I like this one to be the longer is because of this spike right here, right? Between 60 and 65, we have 4 worms. And on this side, between 60 and 65, there's only 1 worm. So I think, on average, histogram A has longer worms. Okay? Part B. For which container would 15 millimeters be a reasonable description of a typical length of worms in the container? What do you think? For which container would 15 millimeters be a reasonable description for a typical length of the worms? Okay, so 15 millimeters. Let's find that on both of these. Here's 15 millimeters on this graph. That doesn't look very typical. Here's 15 millimeters on this graph. Now, it is still pretty far to the left, but notice how many are on this side compared to how many on this side. There are 10, 11, 12, 13 on this side, and 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 on this side. That's pretty darn close. I think this one is B. Let's see about this side. On this side, there's only 1. Well, there's way more than 1 on this side, so it's definitely not A. Okay? Part C. If length is related to age, which container had the most young worms? Well, if the shorter the worm, the younger they are, then this is going to have to be B. B. Sorry, I was looking at the wrong one. B. Because A was the one with the longer worms, right? A is the one with the longer worms, so B is the shorter worms, which means that they are younger. So this is going to be histogram B has the younger worms. Okay? So there's the answers to number 5. Last one is a review from lesson 15 of unit 6. Okay, so this has been a while, but I think we can handle this one. Diego thinks that x equals 3 is a solution to the equation x squared equals 16. Do you agree? Well, if I put 3 in for x, is 3 squared equal to 16? Do you agree with that? Well, remember, when we have an exponent like this, that tells us how many times to multiply the base. So 3 squared is 3 times 3. Does that equal 16? No. 3 times 3 equals 9. 9 does not equal 16. So no, I disagree. And it says explain or show your reasoning, so I think I've shown it pretty well. I think I'm done. And this was my work from that other problem, if you remember, right? So just ignore that because I was using the scratch paper. Okay, so we are now done with our homework for lesson 9. Congratulations, you guys are working so hard. You are now ready to do the Check Your Understanding quiz for lesson 9. Dive into that. I know you'll do awesome because I know you will always
do your best because you deserve your best.